Think about your morning routine. The first thing you do, reach for that trusty tube of toothpaste. Colgate toothpaste, to be exact. It's so familiar, so essential that we barely think about it. But have you ever wondered what it takes to make something as simple yet indispensable as toothpaste? That little tube sitting on your bathroom counter is the result of centuries of innovation, meticulous farming, high-tech manufacturing, and cutting-edge science. Today, we're diving deep into the fascinating world of Colgate toothpaste, from the farms where some of its ingredients begin, to the high-tech factories that transform them into the minty paste that keeps your smile bright. Let's begin this extraordinary journey. To truly appreciate Colgate toothpaste, we need to take a step back in time. It all started in 1806, when William Colgate founded a small business in New York City selling starch, soap, and candles. Little did he know, this humble venture would evolve into a global powerhouse for oral care. Fast forward to 1873, Colgate introduced its first toothpaste. But get this, it came in jars. That's right, the squeeze tube we all know and love didn't exist yet. In 1896, Colgate revolutionized the market by packaging toothpaste in collapsible metal tubes, a move that not only made it more convenient, but also more hygienic. Over the decades, Colgate has led the charge in innovation. In 1955, they launched the first commercially available fluoride toothpaste, scientifically proven to fight cavities. Today, Colgate is sold in over 200 countries, and billions of people trust it daily to keep their teeth clean and healthy. But what goes into making this world-famous product? Let's start with the ingredients. Behind every tube of Colgate toothpaste is a carefully curated blend of ingredients. These aren't just random chemicals. Each component is chosen for a specific purpose, working together to create a product that cleans, protects, and freshens. Fluoride is what makes toothpaste more than just a minty paste. This mineral strengthens enamel, fights cavities, and protects teeth from decay. Fluoride can be sourced from naturally occurring minerals like fluorite or synthesized in a lab to ensure purity. Abrasives like hydrated silica and calcium carbonate are the unsung heroes of toothpaste. They gently scrub away plaque and stains without damaging enamel. These materials are mined from the earth and refined to meet Colgate's strict quality standards. Ever noticed how toothpaste stays smooth and doesn't dry out? That's thanks to humectants like glycerin and sorbitol. Glycerin, often derived from plant oils, and sorbitol, sourced from fruits or corn, keep the paste moist and pliable. Binders like xanthan gum ensure that toothpaste holds its form, whether it's squeezed onto your brush or sits on the shelf for months. That refreshing burst of mint comes from natural oils like peppermint and spearmint, as well as synthetic menthol for a consistent flavor. To keep the product stable and visually appealing, preservatives like sodium benzoate and food-grade colorants are added. While fluoride itself isn't farmed, many of the natural ingredients in toothpaste begin their journey on farms. Glycerin, for example, is extracted from plant oils like coconut or palm. Sorbitol, another key ingredient, is often derived from corn, which is cultivated in vast fields using sustainable farming practices. These raw materials are harvested, processed, and then shipped to Colgate's factories, ensuring they meet strict purity standards. Once the raw materials are ready, the journey to the factory begins. Each ingredient is transported in specialized containers to preserve its integrity. For instance, glycerin and sorbitol are shipped in temperature-controlled tanks to prevent contamination, while abrasives like silica are packed in airtight bags to keep them dry. This logistics process ensures that every component arrives at the factory in perfect condition. Now let's step into a Colgate mega factory, a marvel of modern engineering. These facilities are meticulously clean, with high-tech machinery humming along to produce millions of tubes of toothpaste every day. Here's how it all happens. Every great product starts with precise measurements, and toothpaste is no exception. In a dedicated weighing station, each ingredient is carefully measured to ensure the perfect balance. Advanced computer systems calculate the exact amounts needed, down to the gram, to maintain consistency across every batch. Once the ingredients are measured, they're transferred to massive stainless steel mixing vats. Here's where the magic begins. Water and humectants like glycerin are combined to create a smooth, liquid base. Xanthan gum is added to give the mixture its toothpaste-like texture. These critical components are blended in, ensuring even distribution for maximum effectiveness. The mixture is stirred continuously using industrial paddles, creating a creamy, homogeneous paste. This process is monitored by technicians to ensure everything meets Colgate's rigorous quality standards. Next comes the flavor infusion. This step is all about delivering that signature minty freshness. Natural and synthetic flavorings are added to the mix, and the entire batch is blended at precise temperatures to lock in the flavor. Factory technicians taste test each batch, yes, really, to ensure the flavor is just right. Before the paste moves forward, it undergoes a battery of tests. Scientists and technicians check. Texture. The paste must be smooth, but not runny. Fluoride levels. The concentration is carefully measured to meet regulatory standards. Taste and aroma. Flavor experts ensure the product delivers a refreshing burst of mint. This rigorous testing guarantees that every tube of Colgate toothpaste meets the highest standards. While the toothpaste is being perfected, the factory also preps the tubes that will hold it. These tubes are made from a laminate material that combines the strength of aluminum with the flexibility of plastic. Tubes are sterilized using UV light to eliminate any contaminants. High-speed printers add the Colgate logo, product details, and batch codes to each tube. Now comes the most exciting part, filling the tubes. Automated machines fill hundreds of tubes per minute with the creamy toothpaste mixture. Once filled, the tubes pass through a sealing machine that uses heat or ultrasonic waves to close the ends, creating an airtight seal. Each tube is stamped with a batch code for traceability. Once the toothpaste is sealed in tubes, it's time for packaging. Here's how the process unfolds. Tubes are placed into cardboard cartons, which are then shrink-wrapped for protection. Cartons are stacked onto pallets and labeled with shipping information. Finished products are stored in climate-controlled warehouses until they're ready for distribution. From here, trucks and ships transport the toothpaste to retailers around the world, ensuring that Colgate is always within reach. Colgate is committed to reducing its environmental footprint. From developing recyclable toothpaste tubes to using renewable energy in their factories, the company is leading the way in sustainability. They've even pledged to make all their packaging recyclable by 2025. Colgate produces over 10 billion tubes of toothpaste every year, enough to stretch around the earth 40 times. It's the first toothpaste certified by the American Dental Association for cavity prevention. So, there you have it, the incredible journey of Colgate toothpaste, from raw materials to the product you use every single day. It's a testament to innovation, precision, and a commitment to oral health. Next time you squeeze a bit of Colgate onto your toothbrush, take a moment to appreciate the science and care that went into making it.
Before we get into the nitty-gritty of ice cream production, don't forget to hit that like button, comment below, and subscribe to our channel for more amazing behind-the-scenes food processing videos. Let's rewind for a moment and look back at the origins of ice cream. Believe it or not, this frozen treat has a history as rich as its creamy texture. It's said that early forms of ice cream were enjoyed by the ancient Chinese and Persians, who mixed snow with fruit and honey. But it wasn't until much later, in the 18th century, that ice cream made its way to America, where it became a massive hit. George Washington and Thomas Jefferson were among the first American fans of ice cream, and since then, it has been a staple dessert in homes across the U.S. Fast forward, the journey of ice cream begins far from the factory, in the green fields of dairy farms. Milk and cream are the foundational ingredients of any ice cream, and the U.S. has no shortage of fresh dairy products, with over 9 million dairy cows producing milk across the country. In an ice cream factory, this fresh milk is delivered daily, often within hours of being collected from the farms. Once the milk and cream arrive at the factory, they're stored in large, refrigerated tanks, ensuring they remain fresh until the production process begins. But ice cream isn't just milk and cream. It's also sugar, flavorings, and inclusions like chocolate chips or nuts. Factories often work with local suppliers to mixing the ingredients. Once the ingredients are sourced, it's time for them to come together. In the heart of the ice cream factory, massive mixers, far more powerful than your standard kitchen appliance, combine milk, cream, sugar, and other flavorings. These mixers are built for efficiency, churning out hundreds of gallons of ice cream base in minutes. It's a process that requires precision. Too much or too little of any ingredient could throw off the entire batch. Temperature control is crucial here. The mix has to stay between 36 degrees Fahrenheit and 40 degrees Fahrenheit to keep the dairy fat stable and ensure the sugar dissolves properly. Advanced machines ensure this delicate balance, blending the ingredients until they form a smooth, consistent base. Once the base is mixed, the magic of ice cream starts to unfold. But we're just getting started. Before any ice cream base can be turned into that delicious frozen treat, it must undergo pasteurization. This process ensures that harmful bacteria are eliminated without affecting the flavor of the ingredients. In this step, the mixture is heated to around 180 degrees Fahrenheit for about 25 seconds, then rapidly cooled back down. Pasteurization is key to making sure your ice cream is safe to eat, adhering to strict FDA guidelines here in the US. This critical step protects consumers from any potential foodborne illnesses and keeps the ice cream fresh longer without the need for artificial preservatives. The next step in the process is homogenization. During this stage, the fat molecules in the mixture are broken down into smaller particles, ensuring the mixture has a uniform texture and flavor. If this step is skipped, the fat in the cream can separate, leading to an inconsistent product. Homogenization guarantees that every scoop of ice cream will have that smooth, rich texture we all love. In a factory, this is done using specialized machines that apply high pressure to the mix, forcing it through tiny valves that evenly distribute the fat molecules. This is a crucial moment, as it's where the creaminess of the ice cream is locked in. After the homogenization process, the mixture is sent to aging tanks where it rests for up to 24 hours. This might sound like a lazy step, but it's essential. Aging allows the flavors to meld together and the fat in the mix to crystallize, which gives the ice cream its perfect creamy consistency. The mixture is kept at a cool 40 degrees Fahrenheit during this period, and large stainless steel tanks help maintain the temperature to ensure the quality of the product. It's here where patience is key. Rushing this step could lead to a grainy texture in the final product. Once the base mix has aged, it's time to add the fun stuff. This is where the ice cream starts to take on its distinct personality, with flavorings like vanilla, chocolate, strawberry, or even more adventurous options like salted caramel or cookies and cream. Factories use giant vats of flavorings which are carefully measured and blended into the base mix. But it doesn't stop there. Inclusions, think chocolate chips, cookie dough, or nuts, are added at this stage, giving the ice cream its signature texture. Special machinery is used to evenly distribute these mix-ins so that every bite is packed with flavor. Now we're getting to the part where the mixture transforms from a creamy liquid to the ice cream we know and love. The mix is pumped into continuous freezers where it's churned and rapidly frozen. The temperature here drops to an icy -22 degrees Fahrenheit, and air is whipped into the mixture to give it that light, fluffy texture. Without this step, you'd end up with a rock-hard block of ice instead of creamy, scoopable ice cream. Once the ice cream has been churned and frozen, it's ready to be packaged. Massive automated machines fill pint-sized containers, quarts, and even industrial-sized tubs with ice cream containers at high speeds, rapidly dropping the temperature and ensuring that the ice cream doesn't develop any ice crystals, which can affect both taste and texture. Now that the ice cream is hardened and ready, it goes through rigorous quality control checks. Samples are taken from every batch to ensure that the flavor, texture, and overall quality meet the factory's high standards. Quality control teams test for things like consistency, sweetness, and the distribution of inclusions. Not only does the factory ensure the ice cream tastes great, but it also has to meet safety and regulatory standards. The FDA has strict guidelines for the production of ice cream, and these checks ensure that every pint is up to code. Chain, keeping the ice cream frozen at all times to prevent it from melting or losing its texture.
From fertile groves under the Mediterranean sun to high-tech food processing plants, the journey of olive oil is a fascinating blend of agriculture and modern innovation. In today's video, we'll take you step by step through the entire process, from planting the olive trees to pressing the olives and bottling the oil. Stay with us until the end to discover the secrets behind different grades of olive oil and the challenges that farmers face along the way. Don't forget to subscribe to Pure Farm and like this video if you enjoy content like this. Your support helps us create more videos and dive deeper into fascinating food production stories. Olive farming. From sapling to mature tree, the journey of olive oil begins in expansive groves that stretch across regions like California, Spain, Greece, and Italy. Farmers carefully select the variety of olives depending on climate, soil conditions, and the flavor profile they aim to produce. Soil preparation and planting. Farmers prepare the land by plowing and loosening the soil to allow for better root development. Olive trees thrive in well-drained soil, and farms located on hillsides benefit from natural drainage. After the land is prepared, saplings are planted in rows with enough space to ensure air circulation and sunlight exposure. Modern farmers employ drones and AI sensors to monitor soil moisture and nutrient levels. This reduces water wastage and ensures that the trees grow healthy from the start. However, olive trees are known for their resilience and don't require much water compared to other crops. Growth and tree maintenance. It takes between 3 to 5 years for an olive tree to start bearing fruit. During this period, farmers focus on keeping the trees healthy through pruning, irrigation, and pest control. Pruning for better yield. Pruning plays a crucial role in olive farming. Removing old or unproductive branches allows new shoots to grow, which leads to higher yields. Well-pruned trees also benefit from better sunlight exposure, which enhances fruit quality. Sustainable irrigation. Although olive trees are drought-tolerant, farms use precision irrigation systems to maintain ideal moisture levels during the growing season. By monitoring soil and plant health through sensors, farmers can irrigate just enough to boost productivity without wasting water. Harvesting the olives. Manual versus mechanical methods. Harvesting is a delicate operation that greatly affects the quality of olive oil. Farmers must choose the right time to harvest, typically between October and December, depending on the variety. Harvesting too early yields oil with a sharp flavor, while late harvesting produces smoother but less aromatic oils. Handpicking for premium oil. On smaller farms, handpicking is still a popular method. Workers carefully collect olives to prevent bruising, which could affect the oil's taste. Hand-picked olives are often used to produce extra virgin olive oil. Mechanical harvesting. On large farms. Larger farms employ tree shakers and harvesting machines. These machines gently shake the branches, causing the ripe olives to fall onto large nets spread under the trees. This method is faster and more efficient, especially for mass production. Once harvested, olives must be processed within 24 hours to prevent fermentation, which could spoil the oil. Transporting and sorting olives at the factory. After the harvest, olives are placed in crates to allow airflow, reducing the risk of mold and fermentation during transportation. Factories located close to the groves ensure minimal travel time, preserving the freshness of the fruit. Sorting and cleaning the olives. Upon arrival at the factory, olives are sorted to remove leaves, twigs, or any damaged fruits. This step ensures only high-quality olives move forward for processing. The sorted olives then go through a washing machine to remove any dirt or dust that may have accumulated during harvesting. Crushing the olives. Breaking down the fruit once cleaned, the olives are sent to crushing machines. Traditional factories use large stone mills to crush the olives, while modern facilities employ high-speed metal crushers. Crushing transforms the olives into a thick paste containing oil, water, and solids. This step is crucial as it allows the oil droplets to start releasing from the pulp, but careful control is needed to avoid overheating, which can affect the final flavor. Malaxing. Bringing the oil together, the olive paste is then transferred to malaxers, where it is slowly churned for 20–40 minutes. This process helps the tiny oil droplets merge into larger ones, making extraction more efficient. Malaxing must be done at low temperatures, cold extraction, to preserve the oil's flavor, aroma, and health benefits. Factories often monitor the temperature carefully to ensure the final product qualifies as extra virgin olive oil. There are two main methods used to extract olive oil: cold pressing and centrifugation. Cold pressing in traditional systems, the olive paste is placed between layers of mats and pressed to extract the oil. This method is labor-intensive but produces some of the highest quality oils. Centrifugation. In modern factories, centrifugal machines spin the olive paste at high speeds, separating the oil from water and solids. This process is faster and more efficient, allowing large-scale production without compromising quality. Filtration and quality control. The extracted oil undergoes filtration to remove any remaining solids or impurities. Some factories produce unfiltered oils, known for their cloudy appearance and stronger taste, while others prefer crystal-clear oil. At this stage, experts test the oil for acidity, flavor, and aroma. Oils that meet the strict criteria are labeled as extra virgin, while others may be refined for different uses. Bottling and packaging. After filtration, the oil is ready for packaging. Bottles are sterilized to prevent contamination, and automated filling machines ensure precise measurements. Most producers use dark glass bottles to protect the oil from light, which can degrade its quality. Labels are added, indicating the type of oil, harvest date, and origin. The bottles are then packed into cartons, ready for distribution. Distribution and export. Once packaged, olive oil is distributed to supermarkets, specialty stores, and restaurants worldwide. Many producers rely on AI-powered supply chains to streamline exports and meet international regulations. Challenges in olive oil production. Despite technological advancements, olive oil production faces several challenges. Climate change, droughts, and extreme weather impact harvests. Pests. The olive fly remains a significant threat to crop yields. Authenticity issues. Fraudulent olive oils are a problem in the industry, prompting many producers to adopt blockchain technology to ensure transparency. The final product, from tree to table olive oil, comes in various grades, each with its unique flavor and use. Extra virgin olive oil is ideal for dressings and dips, while refined oils work best for cooking at high temperatures. From nurturing olive trees under the sun to advanced extraction techniques in factories, every bottle of olive oil tells a story of tradition and technology.
Why is a bag of Lay's chips so enticing? Is it each chip's flavor, crunch, or just plain perfection? From the meticulously cultivated potatoes on nearby farms to the state-of-the-art machinery utilized in megafactories, every bag is the result of a complex procedure that requires months of preparation. We'll learn about the amazing journey of Lay's chips today, from the soil to the store, and how millions of chips are produced every day to satisfy demand worldwide. Lay's chips start their journey on specialty potato farms. Because of their optimal growth conditions, these farms are carefully selected to produce potatoes that are high in starch and low in sugar, making them excellent for crispy, golden chips. Potatoes grown especially for their size, texture, and low moisture content, such as Atlantic, Snowden, and Lady Rosetta, are used by Lay's. These types guarantee that the chips cook through without burning or getting mushy. In order to increase fertility, farmers till the ground months before planting, loosening the soil and adding nutrients and compost. It's crucial to have enough drainage since too much water can damage the potatoes. In order to provide them adequate area to grow healthily, seed potatoes are planted in rows by the early spring. To guarantee accuracy and plant each potato at precisely the correct depth, farmers depend on mechanical planters. In order to reduce water waste, drip irrigation systems are used on modern farms to provide water straight to the roots. To encourage healthy plant growth, farmers use smart sensors to track soil conditions and nutrient levels throughout the growing season. The potatoes are ready to be harvested after 90 to 120 days. They are dug up and automatically sorted by harvesting machines before being loaded onto trucks. To ensure quality control, potatoes that are infected or damaged are thrown out right away. To guarantee freshness, the harvested potatoes are then delivered straight to the Lay's facility. Within a few hours of leaving the fields, the newly harvested potatoes reach the Lay's facility. For the potatoes to maintain their moisture content and quality, time is of the essence. The quality inspection section is the first checkpoint, where automated scanners and factory staff make sure that only the best potatoes are used in production. Rejected potatoes are sent for animal feed or composting if they are too big, too small, or discolored. Conveyor belts carry the authorized potatoes to huge washing facilities. Clean potatoes are prepared for slicing after being cleaned by high-pressure water jets and brushes that remove soil, debris, and any remaining pesticide. While some potato peels can be eaten, Lay's removes the skin completely to guarantee a consistent texture. Friction rollers are used in industrial peeling equipment to remove the outer skin off potatoes without causing any harm. The potatoes go through high-speed slicers after being peeled. With its ability to slice hundreds of potatoes every minute, these machines guarantee that every slice is the same thickness. Every chip will cook evenly when fried because to this uniformity. To get rid of extra starch, the uncooked slices are cleaned in cold water baths. The chips would clump together when frying if this step wasn't taken, resulting in an inconsistent cook. Additionally, this rinse step makes the finished product crispier. Before frying, the slices are gently dried on vibrating conveyor belts to eliminate any last traces of moisture. This is an important step because when the chips are immersed in hot oil, water can create dangerous splattering. Here's where the magic happens. Raw potato slices are turned into our favorite crispy chips. The slices are immersed in hot oil as they pass through massive industrial fryers. To guarantee that the chips fry uniformly, the oil is maintained at a constant 350 degrees Fahrenheit, 176 degrees Celsius. For roughly 3 to 4 minutes, the slices stay in the oil. To keep the chips from adhering together, revolving paddles automatically agitate them. The distinctive crunch is produced as the water within each slice evaporates during cooking. After being fried, the chips go along conveyors that drain excess oil. This guarantees that they stay crisp, light, and not unduly oily. It's time to give each chip its distinct flavor, be it barbecue, sour cream and onion, or classic salted. The seasoning is carefully distributed over the newly fried chips as they pass through revolving drums. With the use of precision sprayers, every chip is perfectly coated, guaranteeing that no mouthful is flavorless. Every chip receives an even seasoning thanks to the drum's revolving motion. Lay's engineers meticulously regulate the seasoning content to provide a uniform flavor in each batch. At Lay's, quality is a given. To make sure every chip satisfies their exacting criteria, the business uses both sophisticated technology and human inspectors. The chips go through laser-guided scanners that look for flaws like discolored patches or burned edges. Chips that fail the test are taken off the manufacturing line and fed to animals. Additionally, Lay's uses human testers to sample chips at random throughout the day for taste testing. To make sure the chips are ideal before packaging, these testers assess the flavor, texture, and crispness. The chips proceed to the packing equipment after passing quality check. To guarantee that each bag contains the proper quantity, the chips are mechanically weighed and portioned. After that, the packaging machines put chips into the bags and use nitrogen gas to keep the chips fresh. Every bag is sealed with heat to keep out air. The chips are shielded from staleness and crushing during transportation by nitrogen gas. The bags are given a batch code and expiration date, which aids in inventory management and, in the event of a product recall, after being packaged, the chips are transported to distribution sites in cartons. They are then sent to supermarkets, petrol stations, vending machines, and grocery stores all around the world. Lay's makes sure the chips are fresh and ready to consume by using an advanced inventory management system. Lay's is dedicated to using sustainable production methods. The facility turns discarded chips and leftover potato peels into compost or animal feed. In Lay's production line, nothing is wasted. Lay's carbon footprint is decreased by using wind and solar energy to power many of its factories. In an effort to cut down on plastic waste throughout its international operations, Lay's is also experimenting with biodegradable packaging materials. And so, from farm to factory, Lay's chips are produced. Every bag is a symbol of the commitment of farmers, the accuracy of food scientists, and the strength of contemporary equipment. You'll understand the amazing journey that Lay's chips have gone to reach your hands the next time you open a bag of them. Today we're going behind the scenes, from the farms where it all starts to the high-tech factory where every bottle is crafted to perfection. Curious? Hit that subscribe button and let's dive into the surprisingly complex process behind the world's favorite chocolate syrup. Creating the perfect chocolate syrup doesn't start in the factory. It starts at the source, deep in tropical regions where cocoa trees flourish. Only the highest quality beans make the cut, hand-picked from sustainable farms where farmers use time-tested techniques passed down through generations. These beans aren't just any beans. They're selected with an emphasis on flavor, quality, and ethical sourcing. Imagine farmers meticulously examining each cocoa pod, ensuring that only the ripest and most flavorful beans are chosen. This commitment to quality and fair trade means that every bottle of syrup you enjoy is rooted in sustainable practices, benefiting communities as well as the environment. Once the precious cargo arrives at the factory, it doesn't just go straight to production. No, the beans undergo an intense cleaning and sorting process. Specialized machines meticulously remove any dirt, debris, or unfit beans. Picture a conveyor belt lined with cocoa beans, where advanced scanners and sorting machines detect and discard any impurities or defects. This stage is crucial because even a single imperfect bean could disrupt the delicate flavor balance. Each bean is examined, cleaned, and sorted with precision, setting the stage for the rich, smooth chocolate flavor we all love. Now it's time to unlock the true essence of the cocoa bean: roasting. The beans are placed in industrial-grade roasters where temperature and timing are meticulously controlled. Roasting is a fine art, requiring a delicate balance to bring out the bean's natural flavors without burning away its richness. The beans are roasted until they reach that perfect shade of brown, releasing intoxicating aromas that fill the factory air. This process develops the bean's natural flavor compounds, creating the distinct chocolatey richness that defines the syrup. Skilled technicians closely monitor each roast, adjusting for factors like humidity and bean size to ensure each batch is just right. With the beans perfectly roasted, it's time for breaking and winnowing. This step separates the precious cocoa nibs from the outer shells. Specialized machinery cracks the beans, and high-speed air streams blow away the lighter shells, leaving behind only the dense, flavor-packed nibs. Imagine each bean being gently cracked open, releasing the nibs that hold the core flavor. These nibs are like little nuggets of pure chocolate potential, and they're about to be transformed into something extraordinary. The nibs now move to the grinding phase where they're crushed and ground into a thick, velvety paste known as cocoa liquor. Don't be fooled by the term. There's no alcohol here. Instead, cocoa liquor is pure, liquid chocolate in its most concentrated form. Industrial grinders work tirelessly to crush every nib, turning it into an ultra-smooth paste that will serve as the base for the syrup. The machinery used in this stage is engineered to grind the nibs to an exceptionally fine consistency, ensuring that every particle is as smooth as silk. This cocoa liquor captures the essence of chocolate, dense and rich, ready to be refined even further. Here's where the cocoa liquor is transformed further. Through a process called pressing, the cocoa liquor is divided into cocoa butter and cocoa solids. Think of cocoa butter as the silky, fatty part, while the cocoa solids hold the intense chocolate flavor. By balancing the two, the factory can control the texture and richness of the final product. Separating these components is a delicate process, but it's essential to achieve that perfect blend of smoothness and chocolatey intensity that's unique to the syrup. With the cocoa components ready, it's time to add the ingredients that make this syrup so irresistible: milk and sugar. In large vats, the cocoa solids are combined with milk powder and a precisely measured amount of sugar. This blending stage is no simple mix. It's a carefully calibrated process that ensures each ingredient melds together seamlessly. The milk gives the syrup a creamy base, while the sugar sweetens it just enough to create that satisfying flavor. These ingredients are combined in exact ratios, achieving the same perfect taste in every single bottle. Of course, there's a special twist to this recipe, a blend of secret ingredients that give the syrup its iconic taste. These ingredients are closely guarded, known only to a select few within the company. Each element in this secret mix has been carefully chosen to enhance the chocolate flavor, adding subtle notes that make every drizzle unforgettable. It's these secret ingredients that set this syrup apart, creating a unique flavor profile that's instantly recognizable. Next up is refining. The chocolate mixture goes through a refining process where it's broken down even further, removing any remaining particles that could affect its smoothness. Imagine huge rollers, pressing and refining the mixture until every last bit of grittiness is smoothed out. This step is critical to achieving that silky, luxurious texture that pours effortlessly, coating every scoop of ice cream or stack of pancakes. This refined mixture is a far cry from the raw cocoa nibs we started with, having been transformed into a creamy, flowing chocolate base. The refined chocolate mixture now moves on to a process called conching, a key step in developing flavor. Conching involves kneading the chocolate in a large machine for hours on end. This slow and steady movement brings out the depth of the chocolate's flavor while eliminating any unwanted bitterness. Think of it as coaxing the best characteristics out of the chocolate, enhancing its sweetness, richness, and aroma. This conching process is what gives the syrup its smooth, intense chocolate profile, ensuring each spoonful is filled with deep, complex flavors. Tempering follows conching, creating a consistent texture throughout the syrup. The chocolate is carefully heated and cooled in a controlled environment, stabilizing the mixture and ensuring it retains its glossy, smooth appearance. Tempering also helps the syrup pour perfectly without separating, maintaining that luxurious, velvety finish we expect. The result is a syrup that's rich, thick, and always ready to add a touch of chocolate magic to whatever it touches. At this stage, the syrup undergoes pasteurization to ensure it's safe for consumption. Pasteurization heats the mixture to kill any potential bacteria without altering the flavor or texture. This crucial step ensures that every bottle is not only delicious, but also safe, giving you peace of mind with every pour. Pasteurization is part of the brand's commitment to quality and safety, meeting the highest standards to deliver a product you can trust. Now comes homogenizing, which gives the syrup that signature thickness. The syrup is run through special equipment that stabilizes all the ingredients, preventing any separation and creating a perfectly even texture. Homogenizing ensures that each bottle has that thick, pourable consistency that flows smoothly, perfect for topping desserts or blending into drinks. After homogenizing, the syrup is gradually cooled to lock in its texture and prevent any separation over time. This careful cooling process stabilizes the syrup so it stays thick and creamy even after weeks in your pantry. This cooling step ensures that every bottle you open is just as rich and creamy as the first. With the syrup finally ready, it's time for bottling. Using high-tech filling machines, each bottle is filled with the exact amount of syrup. Precision is key here, as every bottle needs to have the same amount, ensuring consistency across every batch. This filling process is a spectacle of efficiency and accuracy, minimizing waste and guaranteeing that every bottle reaches you in perfect condition. As soon as each bottle is filled, it's sealed tightly to preserve freshness. The iconic label is added, a promise of the quality inside. Every detail, from the seal to the branding, is designed to ensure the syrup stays fresh and appealing until it reaches your kitchen. Before the bottles leave the factory, they undergo strict quality control checks. Teams of experts taste test, inspect, and verify each batch to ensure that it meets the highest standards. This attention to detail means that every bottle of syrup you enjoy has passed rigorous checks for taste, texture, and appearance. Finally, the bottles are packed in eco-friendly boxes, ready to be shipped to stores worldwide. From the factory to the shelves, each bottle is carefully handled, so it arrives fresh and ready to enjoy. It's a journey of thousands of miles, delivering chocolatey goodness to households everywhere. This brand doesn't just focus on quality, they're also committed to sustainability. From recyclable packaging to ethically sourced cocoa, they're dedicated to reducing their environmental footprint. Every bottle represents a commitment to responsible production and sustainable practices. After this meticulous journey, the syrup finally makes its way into your home, ready to drizzle over desserts or stir into a glass of milk. With each bottle, you're not just enjoying a treat, you're tasting the result of a careful process dedicated to flavor, quality, and sustainability. Thanks for coming along on this chocolatey journey. If you enjoyed learning about how this iconic syrup is made, don't forget to like, comment, and subscribe for more behind-the-scenes looks at your favorite treats. And tell us in the comments, what's your favorite way to enjoy chocolate syrup? Until next time, keep pouring on the sweetness.